Hey folks, Professor Gray here, ready to talk about contingency tables and finding probabilities using them. Data is often organized into contingency tables to facilitate finding probabilities. In particular, finding conditional and compound probabilities is much faster with a contingency table. The table is your friend. Here is a contingency table, sometimes it's called a two-way table, with blood groups and RH types for 98 people. As you can see, they're split up by group, so O has their group, A, B, and AB have their group, and then I've got marginal totals on the ends. Now, not all contingency tables have the marginal totals. If they don't, it's often a very good idea to fill those in on your own to help you answer questions. For example, there are 35 people who have RH positive O blood. There are 6 people who have AB positive blood. There are 9 people who have A negative blood. And there are 21 people who have RH negative blood total. And the total of the total is 98. 98 people overall. All right, number 27 says, if one person is randomly selected, find the probability that the person has blood group A. So we can find this probability using the contingency table that's given. Number 27. First, my notation, probability of A. Well, how many people have blood group A? Well, I would look at blood group A and the total, that's 39, out of the overall total, 98. Now let's find the decimal equivalent of that. We'll round it to 4 places, so 0.3980. That's my answer. Next question, number 28. If one person is randomly selected, find the probability that person is not RH negative. So this would be the probability of RH negative complement. All right, that's 1 minus the probability of being RH negative. So 1 minus, there are 21 people total that are RH negative out of 98 people overall total. Well, let's find the decimal equivalent of that. To 4 places, it's 0.7857. And that's my answer. Now there's an additional way that I could have answered that question. If you're not RH negative, then you have to be RH positive. So I could have taken the total RH positives, that's 77, divided that by the total, and I would get the same thing. Use whatever approach works for you or makes sense for you. Number 29. One person is randomly selected. Find the probability that the person has blood group B or is RH negative. So B or RH negative. All right, now look at the total number of B's. That would be 7 out of 98. Or tells me that I should add. And the RH negatives are 21 out of 98. Oh, but wait. I've double counted someone. If I count all the B's and I count all the RH negatives, I've double counted exactly one person. The one person that is B negative was counted in both groups. So the probability of this happening at the same time, -1 out of 98. It's principle of inclusion-exclusion. Always watch for that when you are adding. Well, let's find the decimal equivalent. And if I round that to 4 places, I get 0.2755. That is my answer. Always watch when you're adding probabilities. Take your finger or your pen and just trace the ones you're adding and see if you overlap anywhere. If you touch an entry twice, be sure to subtract that back out. Number 30. Find the probability that a person has blood group AB and is Rh positive. Well, the contingency table makes and problems much shorter. Instead of doing the multiplication rule, simply use the table. Read the table. If you look at the ABs and the Rh positives, how many people are AB and positive at the same time? Well, AB positive is 6. So there are 6 people out of 98 that are AB positive. Rounded to 4 places, 0.0612. And that's the answer. If you have an AND problem using the contingency table, use the table to find the answer. Number 31 talks about conditional probability. It says that if one person is selected at random, find the probability the person is Rh positive given that they have blood group A. So this is probability Rh positive given that they are A. Now, according to the formula for conditional probability, we can find that by finding the probability of being Rh positive and group A and dividing it by the probability of being group A. I'm going to do this problem 2 ways. I'm going to do it that way first, and then I'll show you how to do it using some logic instead and saving some steps. All right, so the probability of being A and Rh positive is 30 out of 98. Probability of being group A is 39 out of 98. All right, I've got a compound fraction here, so that's 30 out of 98 divided by 39 out of 98, which is 30 out of 98 times 98 over 39. I invert the second fraction and multiply. Okay, that gives me 30, the 98s cancel by the way, over 39, which is approximately 0.7692. And that's my answer. That's one way of doing this problem. That uses the formula. Here's how to do it using logic. Probability Rh positive given that they are group A. given that they're Group A. We're assuming that they are in Group A. So only look at the Group A's. Out of those, how many are Rh positive? That would be 30. And how many total Group A's? That's 39. Oh, this is the same thing I got right up here. So when I round, I'll get 0.7692, which is the same answer and the correct one. I can use a little bit of logic, and I can save myself a lot of steps with these given problems, the conditional probability using a contingency table. Here's the process again. Whatever is given, that's the group or the category or the column or row that I limit myself to. Only look at the A's. Out of those, 30 out of 39 are Rh positive. So I can save some steps. Let's take a look at number 32. Number 32. Find the probability the person has blood group A given they're Rh positive. Well, this sounds almost like the same problem, but it's not. This time, I'm finding the probability of being A given that you're Rh positive. Given, or assuming that you're Rh positive. So only look at the Rh positive people. That would be the first row. The total of those is 77, and the number of those that are group A is 30. Rounded to 4 places, I get 0.3896. So using the logic, I can shorten that process substantially. The table is your friend. Use the table. Well, here's a couple more topics before we end these notes. The actual odds against A occurring are the ratio, probability of A not occurring, the complement of A, over the probability of A, or the probability of A complement with a semicolon, probability of A. That's the odds against A. Odds in favor of A are the reciprocal of those, probability of A over the probability of not A, or probability of A, probability of not A with a colon between. So they're reciprocals. Odds against, the odds against are first. Odds in favor, the odds of it happening are first. Payoff odds against A occurring are the ratio of the net profit, that's if you win, to the amount bet. And they're separated by a colon. You've probably heard that something's a 50-50 shot. Yeah, that would be the probability of something occurring, 50, versus the probability of it not occurring, 50. 0.5 or 50%. You might have also heard I'll give you 4-to-1 odds. This is often talked about with betting, or like in horse races, odds of winning or odds of payoff. What that means is that if you give me $1 and you win, you will win $4. If it's 10-to-1 odds, then if you bet $1 and you win, you'll get $10. Those are how odds work. And that's all for these probability notes.